Greetings, friends and colleagues of the GLOBE community. My name is Gerard Wykes, and this is our GLOBE Learning to Research project, The Mystery of North Shore's Disappearing Pond. North Shore Hebrew Academy High School was constructed 6 years ago on the top of Community Drive Hill, which slopes down to Long Island Sound some 4 miles to the north. One feature that figured into the design was a pond at the front and topographic bottom of the school to serve a number of purposes. First, as a catch basin for 15 acres of sloping school property, much of which is paved parking lot. Secondly, as an aesthetic natural landscape asset. And third, as a natural lab for environmental science and ecology classes at North Shore. Since its inception, the pond has served its purpose as well. Some background: the pond has retaining sidewalls and storm drains that channel water into the ocean in the event of flooding. To provide an idea of the steep topography, one day shortly after the first perennials were planted, it rained torrentially, and a mudslide pushed the entire landscape into the pond. Here are some images to depict the outcome of a costly mistake. Last year's environmental science students noticed that the shoreline of the pond had receded significantly from fall 2011 to spring of 2012. This aerial view from Google Earth supports the observation that the pond is receding. The question is, why? To answer the question, students were selected from environmental science class based on the ability to answer the following skill testing question: would you like to do an extracurricular environmental study with Mr. Wykes? And thus the Pond Squad was born. Here are the areas of our study as we've defined. One group would study the dimensions and rate of recession of the pond. Another would study its drainage and runoff. A third, in collaboration with Peter Dorothy, would study energy absorption. A fourth group would study climate. A fifth, hydrology. And a sixth group would study the liner and soil infiltration properties of the pond. This is our work to date.
Hi, my name is Samantha Blady, and my job is to perform the depth survey in the pond project using this inflatable boat and this bamboo stick marker. And afterwards, the information will be passed to my friend Allie, who will do the mathematical modeling. We have 1 meter and 6 centimeters over here, and then at this point it was measured 1 meter. Here we had 82 centimeters, and over here we have 98 centimeters.
Hi, my name is Allie Paul, and I'm a math nerd. We're going to be calculating the volume of the pond using only basic geometry. Using ongoing measurements, we can calculate both the volume of the pond, the rate of lost water, and the longevity of the pond. First, we're going to determine the length and width of the pond. Then we are going to create an outline. Now we are going to analyze an aerial view of the pond. We are going to superimpose a grid, and in the grid, each square represents 1 meter. Now we are going to analyze the squares and take the measurement of the surface area of the pond using these squares. To ensure that this calculation is correct, we are going to overlay 2 triangles. Now we are going to find the base and height of the triangles, and as we can see from our measurements, the measurement for the area of the pond is in fact correct. Now we are going to bring in Samantha's data. Samantha measured a 1 meter contour around the center of the pond. Now, using 1 meter as the height of an irregular tetrahedron, we can obtain the volume of the pond by using the formula for the volume of the tetrahedron. which is 1/3 base times height. Following these procedures, we obtain a volume of 89.5 meters cubed. The 2007 estimate of the pond's volume is 120 cubic meters. If we analyze the rate of change of the pond, we can expect that in 14 or 15 years, the pond will be just a pit.
Hi, my name is Sam Abayev, and our team study involves drainage at North Shore Hebrew Academy. Our school is built on a slope. The parking lot is built on a higher elevation, and the pond in this area is at a lower elevation. Because of the steep slope of the school, we would assume that when it rains, runoff water would run down from the highest point of the parking lot to the lowest point of the parking lot, found here, and through drainage it would eventually discharge into the pond, which is located at the lowest point of the school. In our experiment, we will empty 30 gallons of colored water located in the garbage can. We will empty 30 gallons of colored water to the lowest point of the parking lot, found here, and hypothetically the water would discharge from the lowest point of the parking lot to the pond.
Here we have blue food coloring that we are adding to 30 gallons of water to pour in here and see if it ends up in the lake over there. So I'm just gonna...
Alright, now we're at the pond, and we're here to see if the water that we poured down from the top discharged down from the drain, and if it came down through this pipe.
Now, as you can see here, there's actually quite a bit of sand within the drain pipe. For further evidence, please come over this way. Now, here, there's even more. Can't even see all that. And it looks like some plant life is growing there too, which means that water has not come down in quite a bit. Now, this blockage may be one of the reasons why the colored water we poured up top did not come down. However, we might want to confer with the school's contractors that the pipe that we poured out onto on top actually leads to this drain pipe.
I'm Shani Borelli, and I'm here for the Globe L2R Pond Project. What's the difference between climate and weather? Climate is long-term atmospheric trends, while weather is day-to-day fluctuations in variables such as rainfall and temperature. For example, 17 inches of precipitation due to Hurricane Irene in August of 2012 would be considered a weather effect. However, increased hurricane frequency can be an aspect of climate change. Studies have shown that climate change is a reality, and the overlying question is whether or not climate change is affecting the volume of our pond. This graph shows the average precipitation in inches in the area around our school over the last 30 years. A linear fit shows the increasing trend, especially over the last 10 years. With all this precipitation, doesn't it make sense that the pond should be getting bigger and not smaller? The rainfall is only part of the picture. What about temperature changes? This graph of average temperature in our region over the past 30 years indicates a warming trend. The resulting evaporation could offset and even overtake increases due to precipitation.
Turbidity refers to how clear or cloudy the water is. Suspended particles in the ponds increases the amount of solar radiation absorbed in the ponds. Absorbed solar radiation increases temperature, which increases the rate of evaporation.
As you see here, sedimented particles fall to the bottom. The water becomes shallow. Because of its shallowness, the temperature rises. This increases the rate of evaporation. What we're doing here is filling the turbidity tube. now going to open the pinch clamp to let the water flow in order that my colleague can see the technique.
Today, the turbidity of our pond is 31 centimeters.
The reason for the turbidity in the pond is because of eutrophication and erosion.
This rubber material shown here is what we suspect that runs throughout the pond and beneath it. As you can see here, the rubber liner is thin, dry, and easy degradable through environmental conditions.
One of the possibilities that the pond has been receding may be because of compromises in the liner.
Our study looks at water loss in the pond over time. We were wondering whether the liner could have developed a leak over the past 6 years, and whether the liner would break. If no, and there's no escape for water downwards, then the only other way the water could go is upwards, i.e. evaporation. We wanted to ask a few questions about the liner. Is the liner made for water? Is the liner waterproof? And is the liner subject to breaking down, i.e. does it have a life guarantee? I'm talking with Mr. Louis Palomo here. I'm going to ask a few questions. We found this at the pond. Is this the liner for the pond?
No, that's not the pond liner. That's for the well.
The well, okay.
It's totally different. For the pond, it's a little thicker.
Okay.
But no, that's absolutely not the one.
Tell us a bit about the what the pond liner would be like. Yeah.
Oh, the pond liner has to be a little thicker than this one. What else I can say?
How old would it be? Yeah.
5 years. It's 5 years old.
So therefore, there's no chance it would be.
There's no chance to have a hole or something there.
Leakage.
A leak.
According to our school caretaker, the liner is most probably intact and probably would provide years of water resistance to the pond. Our hypothesis of a broken pond liner is busted.
Can we form a conclusion? Phone calls to groundkeepers with other ponds confirm our suspicion. Most refill their ponds on a regular basis. The reason why is right beneath our feet.
The layers above the Magathie Aquifer, our source of fresh water, is porous gravel.
Combined with our suburban thirst for water, lawn sprinklers, and wastefulness, the groundwater has dropped steadily such that any runoff heads downwards and not towards the pond.
It seems that the biggest enemy of the ponds on Long Island North Shore is Long Island itself.